Hello everyone. Today we will build a board game from scratch. In this game we have to slide the tiles to arrange the numbers in ascending order. The objective of the game is to arrange the numbers with the minimum number of moves possible. There is a scope to replay the game with different arrangement of numbers. The system also records best move. This game is built in Python and Pygame module is used for graphics capabilities. I have used VS Code as program editor. You may use any editor of your choice. So my driver code goes here. We shall start by importing different modules. So first we are going to import this Pygame module, and then we'll import another module in Python. So we'll start import PyAutoGUI. Then we'll import another module. So we'll write import random. So these are the three modules we are going to import in our game. So here we will write say page width. We will take two variables, page width and page depth, for designing of our game window. So for this we will take the whole window as our page depth and page width. So we will use this PyAutoGUI.size method. So we will take the window size so that we can make our game window dynamic. And then we will reduce our page depth and page width by 5%. So we will write page depth equal to int whatever the page depth we already have into 0.95. So this will reduce our page depth to 95%. And we will copy this and we will change the depth to page width. The very same way we will reduce the width of the game to 95%. The reason we do this so that we can have this cross window functionality. Otherwise we will not have this cross window functionality. Alright, so now we'll init our Pygame module. So for each Pygame functionalities, this is the mandatory for each Pygame. We'll have to init this Pygame module and we'll design a screen. So this screen will act as our game canvas. So we shall write a screen variable, where screen variable equal to Pygame dot display dot set mode. Alright, so here in this set mode we'll pass our page width and page depth. So we'll write page depth and page width and page depth in this screen variable. So this screen variable will act as our game canvas. Alright, so we'll come back here and we shall now declare a Pygame.display method. Okay, so Pygame.display will set a set caption. So in our game we will have the caption. Let's say the caption is called slide game. Alright, so at the top left corner of the game we will have this written slide game. So now we will take a variable running and we will set running as true, so that we will implement a continuous game loop, infinite game loop we will implement. For this we will write this while loop. While this while loop is always true, it means the game will be continuously running. Alright, so we will fill our screen with black color. For this we will write this screen.fill method with 0, 0, 0. So this is for filling our screen with black color. Now we'll loop through all the events in Pygame and we'll try to find the event which we'll use for closing the game. So for this we'll write for event in Pygame.event and .get method, Pygame.event.get method, and here we'll do if we get event.type is equal to, if event.type is equal to Pygame.quit. if event dot type is equal to pygame dot quit, then we will set our running variable as false. We will set running as false. So our game will come to an end. When the user will cross the game window, our game will come to an end. Till the time our game will be continuously running. Alright. So we will do what here? We will do some pygame dot display dot update, so that our game window gets continuously updated, and we will try our code now to see whether we can have a game window or not. Alright, let's go. Yeah, fine. So we have a game window now. Now our game window is completely filled with black color. So we have a game window now. Very good. So till the point we are fine. Now once we have our game window ready, we will try to draw some objects in our game window. Okay, for this we will try to draw our game board here. Alright, for this we will say pygame.draw method, pygame.draw.rect method. Alright, this pygame.draw.rect method, in this we will pass our variable as screen variable we will pass, and we will give a color in which the game window, in which the game board will be drawn. In this color the game board will be drawn. We can take any random color over here, and here we will pass our pygame.rect method, because we want to draw a rectangle over here. So this is the way we can draw a rectangle. This is the starting position of the rectangle. 95, 45 is the starting position of the rectangle, and the rectangle will stretch to a length of 620 and 620. So it is basically a square. Alright, so we will draw a square, and for this, for the drawing to take effect, we will have to write another statement over here, another flip statement we will have to write over here. For this we will say pygame dot display dot flip. So if we write this method pygame dot display dot flip, the square will be drawn in the game window. Alright, we got a red colored square. See, it's almost a rust color square we got here. So this is our game board. So first we have a game window, and in the game window we have a game board where our further game tiles will be drawn. Alright, so far so good. So now we will take all my variables. All the tile related variables we shall declare here. Alright, so first variable we shall take as tiles. Okay, so tiles is a list. So in this way, in this program we are going to implement tiles as different objects, and we will store all the objects in this tiles list. And we shall have tile width as and tile depth, we shall have tile width and tile depth both as 200 pixels. Alright, so we have a tiles list, and we have defined the tile width and tile depth. And now we will declare two variables as rows and columns. So we will initially make the game as 3x3 board game. So our rows and columns will be 3x3. It will be a tuple of 3x3. Then we will take another variable. That variable is called tile count. So our tile count will be rows into columns minus 1. So our tile count will be, so 3x3 there will be 9 cells, and in the 9 cells our tiles will be 8 tiles, and one position will be blank. This position will be used for moving the tiles. Okay, then we will create another variable called matrix. In this matrix we are actually going to store the game result. Okay, so first we will initialize the matrix with blank values. So for this we will write this for statement for in range columns, and at the same time we will write for I in range, for j in range rows. So in this way our matrix in which our game result, we will store our game results, all the results. Initially our game results has 0. Okay, so we do not have anything in our game result matrix. Okay, so as we proceed in the game, we will try to fill up this matrix, the game result matrix. Fine. Now we shall take another variable that is called tile number. Okay, so tile number is another variable. We are going to use this variable. Alright, so this is tile number is also a list, and then we'll we will take another dictionary variable. Okay, this variable will be used as a storing the dictionary. In this board game, we are going to have 8 tiles and every tile has a position in the board. So here we will take predefined positions. In this tile print position, we will take predefined positions. So I have already calculated the positions and I'll write the positions here. Okay, for this dictionary, the first variable, the variable and value concept, the first variable, the variable part, we shall have the position as per the matrix position. Okay, so it will be like 0 0 0 1 0 2. This is the matrix position, and in the matrix position we shall write the actual value. The value will be in pixel where the tile will be positioned. Okay, so for 0 0, the first position of the matrix, the tile position, the tile will start from 100 towards x direction and 50 towards y direction, 100 towards length and 50 towards depth. All right, so in the 0 1 position we shall have 305 and 50. So this is the position where the tile will be drawn. Say 305 and 50 is the position where tile will be drawn. So in this way we are going to complete this 0 1 0 2. So this is the first row is complete. Then we will start the second row, which is 1 0. So 1 0 is my second row and we will complete. So let's do this first. Okay, where all the matrix cells, let us complete all the matrix cells first. So 0 0 0 1, I think 1 2, then the position is 1 2. Then in the third row we will start with 0 2 0 1 0 2, and then we will do 0 1. Well, I'm sorry, 2 0 2 1 and 2 2. So this is the third row of the matrix. Say 2 2 is the third row of the matrix. So we have taken one extra row, I think one extra dictionary position we have taken. I do not think we need that, so I'll delete it. Okay, so in the 1 0 position I'll take 100 and 255, 100 towards the x direction, 255 towards the y direction. So 305 255 is the middle cell, and 510 and say 255 is the third cell. All right, and the last row will start from 100. 100 is the starting position of the last row. Say the eighth cell. This is the position of the eighth cell. This is the where the tile will be situated. 305 480. And the last but not the least is this. This is where the tile will be positioned, 510 by 460. So we have one additional place in the dictionary which we shall remove. Alright, so our dictionary is ready. We will run our code to see that there is no error. Fine, we do not have any error till now. Alright, so far so good. So we have now implemented one dictionary where the tile position, we have predefinedly used all the tiles positions. Alright. So now we will declare a class for tiles. So we will say class tiles and we will write the tiles class definition over here. So we will do a def statement followed by init, and then we will do a self. Alright, so init and then we will do a self. Okay, this is how we will declare a, no, we will not require this, none is not required. Alright, so yeah, this is how we will declare a class. Okay, so and init is the constructor of the class. Alright, so here in the class we will pass the screen, the game canvas will pass the start position x and start position y. So for all the tiles there is a start position x and start position y. We will try to pass here. So this will be the property of each and every tile. So every tile has a fixed position. Okay, so this position will change as the game progress, but at any point of time each and every tile will have a position. Then we will have a number. So this number will be written on the tile, and then we have a matrix position. Okay, so what is the first position is actually the position in the game window, and the second position is actually the position in the game matrix. Alright, so now we will declare, so we have taken all these variables. Now we will define all the variables here. So the color will be fixed for all the tiles. Let's take 0 2 5 5 0. Okay, so this is the color, this is the colors of all the tiles. Alright, then we shall take this screen variable and we'll assign this screen variable to each and every tile object so that the tiles can be printed in the game canvas. Alright, next the tile start position X and tile start position Y. So that every tile will have this attribute so that we know beforehand where the tile, when the system knows beforehand where the tiles are going to be placed in the game window. So this is where the tiles will be placed, start position X and start position Y. So this is where the tiles will be placed in the game window. Alright. Then we shall have this another self dot, we shall have the self dot number. So this is the number that is going to be written on the tile and this number will be a random number between 1 to 8. Alright, we'll come to that point when we create those tiles, and the tiles width and depth will be fixed, which we shall come from our driver program. So this is the tiles width and this is the tile depth. Alright, this is the tile depth. Alright, so we have now this tile width and depth. Alright, so now we shall have this matrix position. Okay, so we shall have another attribute called selected. Okay, once we select a particular tile, we want to make the tile selected as true or false. So by default all the tiles will be selected as false. By default all the tiles will be selected as false. Now when we mouse click on any tile, we will change the select to true. Okay, and we shall have another property here that is called self dot position, self dot position. Okay, this self dot position X. Self dot position X is actually its matrix position, the matrix position of the tile in the game. So I have already mentioned that there are two positions of the tile, one the position of the tile as per of the game window and another position as per the game window, and another position of the tile is as per the positioning of the tile in the game matrix. By this way we can know how the game is progressing. We will capture all the movements of the tiles in this matrix. Alright, so we have this position X and position Y, matrix position X and matrix position Y. So we have another variable called movable. Okay, so in the game window not all the tiles are movable. Okay, we shall identify as we write the programs, as we go on writing the programs, we shall identify all the tiles with this movable functionality. Okay, the tiles which are movable can only move, others cannot move. So our class definition is ready. Now we will try to write a function so that we can create tiles. Okay, for this we will create a function called create tiles and we will write the function definition here. The function call was there in the driver program, and here outside the driver program here I think, yeah, here we shall do this definition of this create tiles. Okay, so while creating the tiles we shall use this random module. Okay, we shall have this random module for creating the tiles. We shall take this I equal to 1 variable and we will loop through this I variable. Okay, while I is less than my tile count. So I have a tile count row into column minus 1. So in this game when my row and column both are 3, my tile count is 8. So I will loop through this till I reach 8. So that I can create 8 tiles. For this I will take a random number. So R equal to random dot rand init. I think I will take rand init. Yeah, I will take rand int, and this rand int I will take a random variable between 1 to tile count. I will take a random variable between 1 to tile count. Alright, so I will take a random variable between 1 to 8. Alright, so if this number has not repeated yet, okay, so for this I will write this if R is not in this tile number. Okay, so whatever the tiles I am creating, whatever the tile object I am creating, I will push them, I will append them into this tile number list. Alright, so if the number is not already generated, then I will take this number as an input in my tile number. Okay, and I will increment my I variable so that I will know that I reach at the last of this while statement. Alright, so tile number. So initially the tile number I shall take as none. Alright. So I will take another variable p equal to 0 and I will try a for statement. For I in range 0 to rows. Okay. So now I will create the tiles for the rows. Alright. So number of rows for j in range 0 to columns. For I in range 0 to rows and for j in range 0 to columns. Alright. So now if I'll write a if statement here. Now if I have not done it yet, if I, so whatever my I variable, if I is equal to rows, it means my rows is 3. If I equal to 3 minus 1, now if I equal to 3 minus 1, it means I equal to 2. If my I equal to 2 and my j equal to 2, it means all my tiles have been created. Okay. If my, because in the last cell of the matrix will be 2 by 2 will be the last cell of the matrix. So if I have this q2, then I will do nothing, then I will pass. It means that I will do nothing. If I have not reached this condition yet, any other condition yet, so I will create this tile object. Okay. For this I will call the constructor of the class tiles, and I will pass my screen variable there. Alright, I will pass all the variables which are needed to create the tile object. Okay, for this I will pass the screen variable and all the variables. Let's say tile print position x, tile print position. Okay, so tile print position, here I will pass ij. Okay, so this will go like this: 0 0 0 1 0 2 for the first row, 0 0 0 1 0 2, and it will go like this. Alright, tile position 0. So this is my x value, and if I change the 0 to 1, I will get my y value. So tile position ij1. So if I get tile position ij, if tile position ij is equal to 1, tile position ij, then followed by 1 in the cell, tile position ij, yeah, right. For this tile position ij1, if this tile position is ij1, so this is my y value. Alright, this is my y value. Okay, then I will pass this tile number. Yeah, then I will pass this tile number for the tile, and then followed by I and j. So this is actually the matrix position. I and j is the matrix position of the tile. Alright, so tile number and matrix position of the tile. Then I will append my tile. So whatever the tile object I have created, I will append this in my tiles list. The tiles object I have created as t variable, this I will append to my tiles list, so that I can have a list of tiles now. Alright, so this is how we are going to create one tile. Right, this looks good. Alright, so for I in range 0 to rows, yeah, this looks okay. Alright, now we shall do this matrix I. Okay, so matrix is the matrix I. Alright, this matrix I and j, matrix ij. So this is the position, so this I will do this tile number. So matrix ij, initially in the 0 0 0 1 0 2 like this, it will have my tile number. Alright, I will run my code. There is an error. Let's go. this line number 29. There is an error at line number 29. Okay, it looks some syntax error. Tile number 29 is here. Let's go at the end of the line to see whether this, what is this error. Line number 29, say tile ij0 is fine. Sorry, let's go back here. ij1, then tile number k, yeah, let's run it again. Okay, we have another error at line number 29. Now the syntax error is unmatched brace I have. Okay, unmatched parenthesis I have. Okay, let's see what is this problem, what is this issue. All right, let's change it back. Let's give it a try. Let's check it here. Tile position ij0. All right, yeah, I think yeah, no, still not done. There is some another error. That error was gone. Another error at line number 29. It says list is out of range. All right, why is this coming? List is out of range. Which list is out of range? Index error. There is an index error. All right, so let me check. Yeah, what is this? K equal to 1. What is this problem? Yeah, this tile number are not in tile number append. I'm appending the tile number here. Tile number is initialized as blank. Yeah, tile number. All right, let's check this. I think there's an indentation error. Let's check. Yeah, tile number. Yeah, let's change the indentation. All right, let's try this code again. Let's run this code again. Everything looks good. All right, let's go. Yeah, now we have resolved the errors. Till now we are good to go. So we have created all the tiles. So the tiles class is ready with me, and I have also created the tiles object. All right, so my tiles object, now I have to draw the tiles on the game window. All right, for this I will create a method. This method will draw tiles in my game window. So the name of the method I have given draw underscore tile self. Okay, self is the keyword we shall have to give for all the methods. So for self, all right, so this def draw style self. Pygame dot draw dot rect. So for the drawing the tiles, we'll do this rect method, and we'll pass this self dot screen for drawing. The game canvas we will provide. We shall provide. Then self dot color, the color by which the tiles will be written, the tiles will be drawn, the color, and self dot this depth. All right, let's do this. This is pi auto GUI, no, pi, not pi auto GUI, this Pygame, yeah, Pygame dot draw, Pygame dot rect, yeah, Pygame dot rect method. Okay, so Pygame dot rect method is for actually drawing a rectangle in the game canvas. So in this case, in our case, it is a square. All right. So Pygame dot rect start position X and start position Y. Okay, so this is the position where the tile will be drawn. All right, and the width and depth of the tile will be like this: self dot width and self dot depth. Alright, self dot width and self dot depth. Alright, so we have this Pygame dot draw. Alright, then we shall have to assign, we shall have to draw the number. We shall have to draw the number onto this tile. For this, we'll take this num variable where we'll have this rendering functionality. So font dot render, the self in the number we have the number of the tile, will convert it into string and will render the string and will store the rendered string in this num variable. Okay, so this is the color for drawing this number. Alright, it's good. Then screen dot blit will actually illuminate, will actually blit this number, this tile, this number will whatever the written as a number onto this tile. Alright, self dot start position x plus 40. Okay, because start position is as the very corner, top left corner. Okay, from top left corner we will move towards 40 pixel. For writing this game number will move towards 40 pixel. Alright, in the 40 pixel towards x direction, 40 pixel towards y direction, 10 pixel towards y direction. Alright, yeah, I think this draw is done. Then we'll actually have to invoke this method from our driver code. Okay, so for this we'll go inside while running and we shall call this. Now we'll implement a loop over here for I in range 0 to tile count, for I in range tile count up to the tile count for each and every object. So tiles I is the object, for this object I will invoke this method draw tile. Yeah, I will invoke this method draw tile. Alright, this looks good. Now I will run this code to see, but there is an error, draw tile, determine draw tile. Oh, so it means some typographical error is there. Let's correct this tiles. Let's correct the spelling of the tile, TYLE tile, and run this code again to see. Yeah, we have another problem. Name font is not defined. Okay, so I'll have to define a variable. In my driver code. So one font variable needs to be defined in my driver code. Let's define the font. Alright, let's come here. Font equals to Pygame dot font starts with capital and we have this font. Alright, let's take this font, free sans bold. Let's take this font, free sans bold, for writing the number onto this tile. Alright, let's okay, fine. Yeah, now my game board is coming fine. Let's run this code again to see. Yeah, and every time I'm running my code I am having different numbers. Okay, the position of the numbers are different. So now I have my game board ready. Alright, so I have a tile class ready, I have tiles, create tiles function ready. Now I have this draw tile and I am actually drawing the tiles. Alright, let's come here. Alright, so let's write some mouse hover functionality. Okay, once I move my mouse onto a tile, the color of the tile should change so that I will know that I have moved to a particular tile. For this I will do this mouse hover. This is a very simple method, by the way. This mouse hover, in this mouse hover I will just, when I will check whether my position, the position of the mouse, I will check my position of the mouse. Okay, for this I'll invoke another event. I'll take help of another event in the Pygame module, and I'll check my x position and y position of the mouse, and my x and y position of the mouse falls in any particular tile. I'll change the tile of the color of the tile. Alright, for this, say this xm motion, say mouse motion at the x direction, if its start position is greater than start position x and is less than my start position x plus my width, tile width. If it is more than start position x plus my tile width. Alright, self and width. Okay, if it is in between this, and similarly if also y direction is also, the y location of the mouse is also in between my xm motion, then ym motion. Okay, then if ym motion is also greater than my self dot start position y, if it is greater than my self dot start position y and my y motion is less than my start position y plus my depth. Okay, so if the position of the mouse is in between a tile object, so this is how I will know whether the position of the mouse, whether I have moved the mouse to a particular tile. So if I have moved the mouse to a particular tile, then I'll change the color of the tile. Let's change the color of the tile. So self dot color equal to, let's say 255, 255, 255. It means white. It means white. 0, 0, 0 is black, and 255, 255, 255 is white. Else, if it is not that, if I have not moved there, or I have moved my mouse further, then the self dot color will remain what it was as before. Alright, 255, 165 and 0. Alright, so now we have this mouse hover. Now I have my definition of mouse hover is ready, but for actually this mouse hover to run, we'll have to write some code in my driver code. Okay, so in my driver code, in the events section, let's go there. Let's go inside the driver code and let's go inside this event part. Right here where I am checking all the event for event in pygame.event.get, where I am getting all the events and I am checking whether I am getting the event that I am looking for. Here I shall check for mouse motion. Alright, so here this event dot type, if my event dot type is equal to this pygame dot mouse mouse motion. Okay, if I get my mouse motion function triggered, mouse motion event triggered, then I shall take the position of the mouse into two variables, that is called xm motion and ym motion. The position of the mouse will be taken in two variables. The one is x variable, another is y variable. Alright. This pygame.mouse, pygame.mouse.get position. Yes, the position of the mouse. I will take the position of the mouse and I will store the position of the mouse to two variables, xm motion and ym motion. Alright, so now I have my motion variables with me. With these motion variables, I shall call this my hover method. Okay, for this I will loop through all the objects I have. For x in range tile count. So x will move through tile count, and here, so for this tile count I'll invoke this tiles, this objects. For this object tiles I object, I shall invoke this mouse hover method. Alright, Alright, and I'll pass the XM motion and YM motion. I'll pass the mouse position, and my mouse position I have passed. Now if I run my code, alright, up to this point it looks good. Yeah, if I run my code, I have an error over here. The name I is not defined. Did you mean ID? Name I is not defined. Alright, here I is not there. Okay. So I'll have to check this back. Alright. For alright, tiles I, but there are no I variables. Alright. Yeah, let's change it back to I variable. Yeah, now if I move my mouse, yes, now my color is getting changed. Alright, so yeah, this is a hovering function. It looks like I'm playing piano. Alright, the hover functionality is done. Alright, so we have created the tiles. So tiles class was there, we have created the tiles, we have positioned the tiles, we have drawn the tiles in the screen. Now we have done this mouse motion functionality. This mouse motion functionality, if I am moving on a tile, the color of the tile will change. Okay, so by doing this, I shall have a hovering functionality. I shall have a hovering functionality on the tile. Alright. So far so good. Alright, so this event.types if pygame.mouse motion, this looks good. Yeah, XM motion and YM motion, this is looking good. Okay, for this range, yeah. Alright. So now I have this mouse motion. Now I have to implement this select. I have to implement the select. Now if I click on a particular tile, I should know that I have which tile I have clicked. Alright, the system should know which tile I have clicked. Alright. For doing this, let's have another method. Let's have another method for doing this. Alright, let's go back. Alright. So yeah, let's take a variable called mouse press. So if I press the mouse on a particular tile, I'll change it back to true till but I have declared it as false. Alright. Yeah, XM click and YM click. Okay, these two variables I shall require. To know that whether I have clicked on a particular tile or not, and when I will release my click, the system should know at which location I have released the click. Alright, so for this I have two variables, XM click release and YM mouse click release. So these two variables I have taken. Now let's write another method. For mouse click. Alright, so mouse click. Yeah, self, we shall have to pass mandatorily self and this XM click and YM click. These two variables I have taken. So I shall pass this two variables mouse click. Now if XM click, if my mouse click, now I'll have to check whether the mouse click, I can do mouse click at any position in the game window, but I shall have to check whether I have clicked my mouse onto a particular tile or not. Okay, so for this I shall check if the clicking position of the mouse, if it falls in between the area of any tile or not. So if it is greater than start position x and start position x plus self dot width. Alright, and the same thing we shall write by exchanging the x with y variable. Okay, the YM click. Alright, the YM click is greater than self dot start position y. This self dot start position y, and YM click is less than self dot Yeah, it is self dot start position y plus self dot depth. Yeah, so if my mouse click falls on a particular tile, so this is how we'll identify whether I have clicked on any tile or not. If I clicked any tile, I shall change the tile to selected. The selected attribute of the tile will be changed to true. Okay, initially while I was creating the tile, I have made like this, that all the tiles are selected as false, otherwise the tiles will be selected as false. Otherwise the tiles will be selected as false. Self dot selected is equal to false. All right, so mouse click functionality we have written. Now we'll have to actually invoke the mouse click. So how do I do that? I shall go to this into the driver code. In the driver code I shall go to here. All right, what is this? Proxy authentication required. What is this proxy? Yeah, I don't need this. I don't need this turtle and proxy authentication. I don't need this. Okay, let's get rid of it. All right. So let's come back here. Say once I am clicking the mouse, it means my mouse click is down. There is a event for identifying this. So if event type, so if event type is equal to pygame dot mouse button down, pygame dot mouse button down, yeah, pygame dot mouse button down, it means that I have made a mouse click. All right, so here I will record my mouse position. For this I shall record my mouse position. For this I shall write the two variables I have taken. All right, firstly I will do this mouse press as true. All right, mouse press as true. This is one variable which I shall make as true. Then xm click and ym click, then mouse click, xm click and ym click, these are the mouse click position, xm click and ym click, the mouse click position. Then I shall take this pygame dot mouse dot get position. Okay, so whatever the mouse position I got, I'll store the values in xm click and ym click, and then I shall traverse through all the objects, all my tiles object. I shall traverse through all my tiles object to check which tile I have selected. Okay, which tile I have selected, and then my global variable mouse press will be as true. All right, so tiles I dot mouse click, yeah, this is one method I have implemented. Okay, so here I shall pass my mouse location, xm click and ym click. This mouse location I shall pass here, this mouse location I shall pass here, xm click and ym click. All right, let's review this. Yeah, it seems okay. Now if I come here, yeah, if I click on this, yeah, okay, it is, I think it is working. At least there are no errors till now. Okay, up to the point we are good. All right, so let's go back here. So now we have a mouse click. Now we shall have to write another method that is called mouse click release. Once I do a mouse button up, my tiles will be released. All right, so mouse click release. In the mouse click release I shall pass my this two variables, xm click release. When I am doing this mouse button up event, I shall implement this mouse button up event, this xm click and ym click. XM click and YM click. Yeah, I shall move this. I shall do this XM click and YM click. All right, now I'll do the same code to find out whether I have say the mouse release, where is the actual location of this mouse release. What is the actual location of this mouse release? If the mouse release is done within the game window, if the mouse release is done outside the game window but inside the game canvas, so this is the position that we want to know. All right, so for this, self dot selected is equal to false. All right, let's try this code. Yeah, it is running. All right, we are good till now. This mouse click release, so mouse click release is fine. All right, now we shall implement one method that is called moving tile. All right, so for the tiles movement, we shall do another method for this tile movement, and in this tile movement we shall change the location of the tile. Okay, so we shall be selecting a tile, we shall drag a tile, and we shall release our selection. Once the release of selection is done, then we shall have, like, we will like to have a feel like this particular tile is dragged to another position. Okay, for this we'll simply change the tile start X and tile start Y. The self dot start position X and start position Y. So if I change the start position X and start position Y of the tile, I shall have a feel like I have moved this tile. All right, so self dot start position Y, Alright, now I'll have to invoke this object, I'll have to invoke this method from inside my driver code and from within my event section. Okay, where I'm playing with all the events. Yeah, the mouse motion, mouse down, mouse motion, logic for mouse movement. Shall traverse for I in range in tile count 0 to tile count. We shall traverse in 0 to tile count, and then we shall invoke this move tile function. Now if my tiles I, it means if my tile object is selected, then only I can move this tile object. So if tiles I is selected and my mouse press is true, so if my object is selected and my mouse press is true, then only I can make this tile movement. So for moving the tiles, I'll simply call the move tile method in all the tile objects. So tile I, where I shall have all the tile objects, and I'll invoke the move tile method in my tiles I. Alright, and here I shall pass my XM motion and YM motion. It means the mouse motion. The mouse motion coordinates I will pass here, so that I can record exactly where the tile needs to be moved. I will run my code to see whether everything is working fine, and I will try and drag in this perfect. So now my object is moving. I am able to move my objects. Alright. So yeah, so far so good. So up to this point, what we have done? So we have done movement of my tile objects. I can literally drag my tile objects, but the problem is my tile objects is going beyond the board game. My tile object is going beyond the board. This is what I do not want. Alright, so I'll have to do something here. Alright, so let's come here. Alright, let's go a little further in the mouse motion and mouse down. Alright. Let's run this code again. Yeah, this is working fine. I can drag my tiles object. Yeah, let me check if I can drag all the tiles objects. Yeah, fine. We can drag all the tile objects, right? So this particular code is working. Now I'll come back here. Yeah, in the mouse button down. Yeah, inside this mouse button down, we shall try to do a detachment logic. Okay, so this detachment will happen when I release my mouse click. So for this I'll invoke this event mouse button up. So when I'll release my mouse click, when the mouse button up will come, then I should be able to detach my tile object. Alright. So for this, since I have released my mouse click, I'll make my mouse press is as false. I'll make my mouse press as false. Perfect. So previously I have declared two variables, is xm click release and ym click release. This is the position where I have released my mouse click. So I'll get my mouse position here. So pygame.mouse.get position. Pygame.mouse.get position will give me this. The coordinates where I have released my mouse click. Alright. It's coming good. So this xm click, and I'll make this xm click and ym click as 0. Alright. Xm click, because I have no longer clicked it. So I'll make my xm click, mouse click, I'll make 0 because I am no longer clicking this. I have released my mouse, so my xm click and ym click should be 0. Initially I'll set my cell found as false. Later, after certain logic, I'll determine whether I have found the perfect cell for movement or not. For this, I'll traverse my list of objects. For I in range 0 to rows. Alright. For I in range 0 to rows, and for j in range, and for j in range 0 to columns. Alright, I'll traverse my rows and columns. I'll traverse length and breadth wise. I'll traverse. Alright. So here, this tile, I'll say tile start position, tile start position x, tile start position x equal to tile start position x equal to tile print position x. Tile start position x equal to tile print position x. Alright. Tile print position x. It means here in the tile print position I am invoking my dictionary. So in the dictionary I'll first have to dictionary. Just remember the dictionary is a variable and value pair. So for this I'll return my ij. Alright, I'll return the ij 0 position and ij 1 position. Ij 0 position is my x position and ij y is my y position. Alright, is my y position. So if my tile print position 0 and 1, for each and every tile there is a predefined print position. So I'll take this print position into two different variables, tile start position x and tile start position y. Now where I am releasing my mouse, if that falls in between this tile start position x and y, it means that I have dropped the particular tile to a perfect location, to a location where a cell can reside. Alright, so to implement this, here I will make the same checking whether the point that I am releasing, my xm release, whether this is my start position x and plus start position, whether it is greater than my start position x and is also greater than my start position x plus my width of the tile. Alright. This tile start position x and release is tile start position x plus start position width, and whether it is greater than my tile starting position and whether it is in between my tile starting position and tile ending position, whether the x is in between my starting position and ending position, and in the very similar fashion I will do the same thing for y as well, whether my y location, whether y location of the mouse is also in between my tile y location start and tile y location end. Tile y location end is simply the tile start position plus the tile length or the tile width as the case may be. Alright. So we have been implementing this logic throughout our project. So to determine whether we have clicked in a right position or not. Alright, so tile start position X and tile start position Y. Alright, so whenever we are releasing our mouse, it means we are trying to drop this particular object, we are trying to drop this particular tile object to a particular position. Now here we will be implementing all this logic. Alright, whether this dropping location is right or not. If the dropping location is right, we shall drop the object over there. If the dropping location is not right, we shall implement a functionality like it will rebound to the original position. Okay, if the dropping position is not right, the object will be rebound. The object will come back to its original position. Alright, so matrix ij. Now if the drop location is perfect, we shall record a movement. If the matrix position, we shall record a movement in our matrix position. So for this, if matrix position ij is blank, then we shall also do a for loop for k in range. For k in range tile count. Okay, we shall traverse the tiles object to see whether this particular thing is working for all the tiles or not, whether this particular logic is working for all the tiles or not. Alright, so tile key means is one tile. So if the tile is selected, then only this particular thing will happen. If the tile is selected true, if the tile selected is evaluated as true, then the following part of the code will be executed. Alright, so here we will try to do this dropping function. So if my tiles k, this means if a particular tile, whether it is a movable or not. So we'll do this letter whether the tile is movable. So we'll do this check mobility. We'll write a check mobility function where we'll see whether a particular type is movable or not. Because all the tiles, we cannot move all the tiles. We can move only those tiles which are adjacent to the blank tile. Adjacent to the blank position, so north, east, west and south, these four positions, we will see whether this particular position is movable, whether the particular tile is movable or not. So we will check two conditions here, whether the particular tile is selected or not, whether the particular tile is movable or not. If the tile could be selected, if the tile could be moved, then only we will say that yes, we have found the cell. We shall take a variable called cell found and we shall set it as true. It means that yes, we have found the cell, and then what we will do, we will swap this. Alright, we will swap. So for this we will take a dummy variable where the matrix for this tile position, the matrix value will be stored. Is matrix tiles k position x, and matrix in the same matrix is the y position, and the x position, it is the x position, and y position is matrix tile k position y. So this matrix position should be swapped. For this we shall implement a swapping method. So we will do this, matrix tile position k, then we shall superimpose this, the next tile which is going to be printed, the next tile we shall superimpose it to the first tile. Alright, so matrix I, right, and then this matrix I, the last tile, we shall set it as dummy. So this is how we shall implement the swap functionality. So matrix ij is the dummy. So now we have swapped it. So if the tile is selected, if the tile is movable, we shall implement the movable logic a few moments from now. If the tile could be selected, if the tile could be movable, then it means that we have found a cell, and then we shall do this swapping. Alright, once the swapping is done for this particular tile, then for this particular tile we'll say tiles k position x. It means tiles k, we shall update the tiles k position is I, and the tiles k position x is j. It means that the tiles position is changed. We have found a new position of the tile. Alright, we shall find the new position of the tile. So x and j. Yeah, perfect. So up to this point, we think we are good. Yeah, this tile position x and y, I and j. Yeah, it's perfect. So then we shall have this tiles k start. So this previously it was the matrix position. Now what about the start position? Now the start position of the tile has also been changed. So we shall do this. Tiles k start position x is equal to tile print position. Yeah, the tile print position. So the tile print position dictionary we have we have declared before. So the ij position, the dictionary value we shall be picked. The dictionary value, the 0 position is the x position of the dictionary value. We shall set it as tile start position x, and in the very similar fashion, I shall just copy this code and paste it here. I shall change this I to x to y and 0 to 1. I shall change this x to y, and I shall change this 0 to 1. It means the original location, original print position, the position of the tile in the game canvas. Whatever the position of the tile in the game canvas, that will come directly in the start position x and start position y. Alright. Let's run this code again. Yeah, no error till now. Yeah. Yes. I am able to move the tiles. Yeah. I am able to move the tiles. All the tiles I can be moved. Yeah, I can move all the tiles here. Perfect. So far so good. Okay, now come back here. So the detachment, tile detachment logic is done. Now we shall implement this check mobility function, whether the tile is mobile or not. For this we shall write a function. Alright. So just come back here in the create tiles, and here we shall call this function. So when we are creating this tile, we shall also check whether this particular tile, the particular tile is mobile or not. Alright, when initially we are creating all the tiles, at the same time also we are checking, and in the downside of the code we shall also check this, we shall continuously check whether a particular tile is movable or not. For this we shall do this function check mobility. Okay, and we are calling this function from the create tile method, and we shall also call this function from our event locations. Alright, so we shall traverse for I in range tile count. It means that we shall traverse through all the tiles. To check what is the position, what is the mobility condition of the tile, whether the particular tile can be moved or not. Alright, so tiles I am taking it into another variable called tile. So tile is equal to tiles I, and then I shall work on this tile variable. Alright. So what is the row index of this particular tile? We shall have to take the row index. It means the matrix position. The matrix position of the tile, we will have to take the matrix position of the tile. For this row indexed is tile position x, and column index is equal to tile position y. Tile position x and tile position y. Alright, it means I am getting the matrix position of the tile. Alright. Then I shall declare a variable called adjacent cells. It is actually a list, adjacent list, and I shall try to record all for a particular tile. I shall try to update this adjacent cells list with all the adjacent tiles. So for a particular tiles, I want to know what are the adjacent tiles. Alright. In the adjacent tiles, I shall append 4 up to 4. If the central tile is selected, then it can be maximum 4 adjacent tiles. All right. If any other position is selected, then it will not be maximum 4. It will not be maximum 4. All right. So I shall append this row index -1. Row index -1. It means the row that I am standing, just the row before I am standing. Okay, if I am standing in the second row, I am talking about the first row and the column index, and I am talking about the same column, the previous row. So it is my north tile. So here I shall have this north tile. Okay, let me copy this 4 times. Let me copy this 4 times, and I shall have this. The first tile is the north tile, and second tile is the south tile, third tile is the east tile, and fourth tile is the west tile. Alright, so in the north tile, I have this row -1, row index -1. What about south tile? South tile, I should have this row index +1. Alright, row index +1. This is my south tile. Alright, in the east tile, I shall have the same row index. But my column index will be column index -1. And in the west tile, I shall have the same row index. In the west tile, I shall have the same row index. Yeah, same row index, and the column index should be, column index will be +1. Right. So this is how I am appending. all the possible. It is not that there will be tiles in all these positions, but this is the possible positions. Okay, only for the central tiles I have mentioned that only from the central tiles there can be 4 adjacent tiles, not for all the tiles. All right, now I shall traverse again. For a particular tile I have recorded all the adjacent tile position. What could be the adjacent tile position? Then for this 4, say there could be maximum 4 values, so I'll traverse the list for 4 times. 4 times I'll traverse this list, adjacent cells list, and I shall check whether this adjacent list falls in my game board. Alright, so if a particular adjacent cell, let's say if the first adjacent cell, okay, let's say if the north adjacent cell is the first adjacent cell. So if the north adjacent cell, whether the north adjacent cell is greater than cells ij, whether its value is greater than 0, it means it is falling in my range. I have a row for all my cells. I have row starting from 0. Okay, so my row is 0, 1 and 2. Alright, so if my row is greater than 0, okay, and row is less than rows, so row is greater than 0 and row is less than 2, row is greater than equal to 0, so it can be 0, 1, 2, and low is less than 2. Okay, so I have 0, 1, 2, and if the adjacent cell, yeah, it is a very same fashion. If the adjacent cell, yeah, let's just come here. If the adjacent cell, this adjacent cell, what do I do? This adjacent cell I, it means the row, adjacent cell first row and 1, row 1, it means the y position, whether the y position is also greater than equal to 0, and whether this y position is also greater than equal to 0, and this adjacent cell is less than adjacent cell I, I2 position, adjacent cell I2 position, whether it is less than, adjacent cell I position, I0 is greater than 0, it is fine, and I0 is less than 2. It means the row wise check I have done. If the adjacent cell 0 and the adjacent cell is less than rows, greater than 0 and less than rows. Yeah, let me do this again. And if the adjacent cell I, if the adjacent cell I first position is greater than equal to 0, and adjacent cell I position is greater than equal to 0 and adjacent cell I1 is less than my columns, right? And adjacent cell I1 is less than my columns. Alright. So it means previously I have appended in my adjacent cell all the possible positions. Now I am checking whether actually these positions have values or not. Whether do I actually have adjacent cells? Do I actually have adjacent cells here in these positions? Alright, if it is there, then I shall say that yes, adjacent cell I2. So adjacent cell I0, I1 and I2, the adjacent cell, this position is true. So this is an actually adjacent cell. Alright, then I shall traverse once again. Well, J in range, length of adjacent cells, G in range, length adjacent cells, J in range, length of adjacent cells. Yeah, this for J in range, length of adjacent cells. If adjacent cells J, adjacent cells J2, if adjacent cells J2, alright. So adjacent cell J2, whether this particular position, now I am checking the column positions, alright. So this particular position this adjacent cell row. Now if my adjacent cell row is equal to adjacent cells, this adjacent cell row, adjacent cells J0. So my adjacent cell row, okay, the same way I shall also do for the adjacent cell column. The adjacent cell column, my adjacent cell column is equal to G1. Alright. My adjacent cell column is equal to my G1. Alright. Yeah. I think this is good. For K in range, I shall traverse again this tile objects. I shall try again this tile objects. Now whether this is matching with my tile objects. So for a particular adjacent cell, I have taken the row and column. Now I shall check whether this particular row and column is matching with my tile objects. So adjacent cell row, if the adjacent cell row matches with the tiles object position. Okay, for all the tiles, let's say for the first tile, if it is matches with the tiles K position, tiles for every tiles we know that we have a matrix position. Whether it is matching with the matrix position, tiles X position, and the adjacent cell column should match with the tiles Y position. So if it is matching with tiles X position and tiles Y position, it means that yes, we have actually found an adjacent cell. It means we have actually found an adjacent cells, and in this game only the adjacent cells can move. In this game only the adjacent cells can move. Alright. So here in the adjacent cells J, adjacent cells J2. Yeah, adjacent cells J2. Yeah. So adjacent cells J2, I shall say this adjacent cell J2 is false. Alright. Alright. Now if the false count, so I shall start with another variable, let's say false count, and I shall initialize false count to 0. Now I shall check how many false count did I get. Alright, for aim in range, I shall take another variable called aim, and I shall traverse in the adjacent cells. For aim in range, if the false count, okay, so I shall try to update this false count. Okay, for aim in range, alright, if adjacent cells m, okay, if for a particular adjacent cells m, if it is false, adjacent cells, if it is true, okay, if it is true, if adjacent cells m2, in this third column, I am taking this variable. So if it is true, it means the tile is movable, the adjacent tile is movable. Alright, in the last part of the code we have implemented whether this adjacent cells third position is true or false. Now I am checking whether the third position is true, it means the cell can be moved. Alright, now I shall do this break, because yeah, there is an else statement where false count, if it is not, the false count will increase by 1, and if I have a false count of 4, if continuously, not continuously, if for a particular tile I got this false count as 4, it means if this false count is equal to 4. So if my false count is equal to 4, it means the tiles dot movable is equal to false. So it means the false count, if for a particular time, so there are 4 times I received a false message, it means the tile cannot be moved. It means, yeah, let's run this code again to see whether there is an error. Yes, there is one error. What is the line number? Line number 72. There is an error in line number 72. What seems to be the problem in line number 72? It says the adjacent cell is less than columns. Adjacent cell is less than columns. Alright, adjacent cell is less than columns. Yeah, let's try this. Yeah, all this can be moved, so there is no problem in the functionalities. Right. Yeah, so far so good. So mobility condition we have done. Now we have to implement this mobility condition. Okay, so while we are doing this drag and drop thing, so in the mouse motion, in the mouse button up, I think, where we are doing this drag and drop thing, here we shall have to check. Now the movable check I have already done. If the tiles is movable, then I am doing this. Swapping. Now here I shall check this mobility. Alright. Yes, it is working fine. Let's drag and drop the tiles. It is working fine. Perfect. Let's drag, let's drag and drop. Yeah, it is still now I'm good. Still now we are good to go. This check mobility function we have implemented. This check mobility function inside this tile button up. Alright, great. This check mobility, right. Now there is a very important thing. Now proper positioning. If the drag and drop is not good, if I have dragged the object and I have not dropped it to a particular cell position, I have dragged the object out of its original position, but I have not placed it to a particular cell position, the object will be rebounded to the original position. For this, if now cell found is 0, now cell found is false. If I couldn't find any cell, alright, what will happen then? For all the objects, for k in range tile count, for all the objects I shall implement this functionality. If the cell found is false, it means that I have dragged the object out of its original position, but I couldn't rest it to a good position, to a desired position. Then if tiles is selected, and if tiles is selected, okay, and tiles k is selected, if my tiles is selected, okay. So if my cell found is false, if I didn't found any cell, and if my tiles k is selected, didn't found any cell, and if I alright, tiles k matrix position x, tiles k position x, right. So if my tiles position, so I shall take my matrix positions, okay. So if my cell found is false, so for a particular tile, I'll take this mat position, I'll take this matrix position, okay. And if for this particular tile, if the start position x, then the cell is not found, then the start position x will be changed back to the original position. Start position x is equal to tile print for this tile print position x. The start position tiles k start position x is equal to tile print position. Now tile print position is my original dictionary. From this dictionary, this variable and value pair is there. So for this variable, so we shall pass this matrix position x. So for this matrix position x and matrix position y, what is my actual print position? So I shall update my x position with that particular print position. Alright. So tiles k start position x and tiles y and tiles k start position y. This will come as this matrix start position 1. Start position 1. So my dictionary, from the dictionary I shall take the values and I shall update my value over there. And if a particular tile is selected on this, so I'll break my condition, I'll run my code to see. Yeah, let's drag and yeah, perfect, it is coming. So if I try to move an object outside my game board, it will come back. It will function like an elastic. It will come back to its original position. But if I drag and drop inside my board, it will come. This 8 is not coming because this is not the adjacent cell. 3 is not an adjacent cell, so it will not. 2 is not an adjacent cell, so it will not come. But 7 is an adjacent cell, it will sit there. 6 is an adjacent cell, it will sit there. But 4 is not an adjacent cell, it will not sit there. 1 is not an adjacent cell, so 1 will not sit here. Okay, perfect. So perfect. My this condition, this logic is working perfect. Alright. So far so good. This proper tile positioning is done. Alright. So now we are good to go with this game over condition. Let's write this game over condition. Okay, now game over condition is very easy for this game. So we shall traverse through all the tiles. In the game board and we shall see the tiles number. So if we get a string 1, 2, 3, 4, 7, 8, then it means that my game is over. So this is my logic this is my game over logic. So for this I will declare a function over here. I'll define a function over here, and I shall let's come back here. So this is where we shall do this. Let's come back here. Alright. Looks good. Yep. Looks good. Yeah. Now let's take a variable, say game over. Okay, and by default I shall say the game over is false. By default my game over is not true, my game over is false. Alright. My game over is false. So here let us take some variables related to my game over. So my game over is false and my game over is banner. When the game over is done, when the game over is true, I want to write in the game canvas that yes, my game is over. So my this is my game over banner variable and game over font. Now I want to use a different font from the tile. When I am writing this game over, I want to use some different font. For this I'll simply copy this and I'll take the same font, I'll just change the size. I'll take the same font, Free Sans Bold TTF I shall take, and I shall just change the size. Alright, I shall change the size. Perfect. Yeah. So my game over related variables are done. My game over related variables are done. Alright. So global, I shall have to declare this global game over. Game over. Let's declare game over as global. Let's declare this game over banner. Game over banner is global. Game over banner is global. Let's declare this game over banner as global, and game over condition is lower. Game over variable is lower. And this gameplay, there is another gameplay count. It means I just want to know how many times I am playing this game. Alright, so we have this gameplay count, and I shall have this best move. So I want to know what is my best move. So for this I shall have another variable called best move count. Alright, best move count, and there is another variable that is called move. Yeah, best move count. Let's not do this right now. Let's not do this. This best move count. Let's do it at some other point of time. Yeah. Let's get over it. I shall do this later. Let's first have this game over condition done. Alright, so here all cell data, let us take a variable called all cell data, and all cell data will be, my all cell data is blank to start with. So for if my all cell data is blank, now I shall traverse in a range once again for I in range rows and for j in range columns, for I in range rows and j in range columns, and I shall look into my matrix. I shall look into my game matrix, because whenever I am making a move, I am recording my move in my game matrix. So if my all cell data, here in all cell data, I am concatenating, I am appending this, I am concatenating this all cell data with this, with this string. I shall convert this. To convert this to string. This matrix, yes, this matrix I and matrix J, matrix Ij. This value, matrix Ij, whatever the value I have in matrix Ij. Okay, so I shall, whatever the value I have this matrix Ij, I shall concatenate. Now if my all cell data comes like 1, 2, 3, 4, 5, 6, 7, 8. Yes, if my all cell data is coming like this, it means my game is over. So I shall say my game over is true, and I shall also print my game over as true. I shall say my game over as true, and my game over banner, I will say game over. The game over banner, I shall do game over. Game over. This print, and I shall also print my game over to know that yes, I have got this game over. All right, good. So sweet. So print game over. All right. There's all cell data 1, 2, 3, 4, 5, 6, 7, 8. This now for let's check this for I in range tile count. For I in range tile count. If my tiles, if my game is over, so then there is no point making those cells as movable. So I shall make all the tiles movable as false and selected as false. Alright, if my game is over, none of the tiles are movable, none of the tiles are selectable. Okay. So tiles I dot selected is also false. Alright. Selected is also false. Good. Let's run this code again. It is running without any error. Let's play a game. Let's play it. Here, you come here, you go there, you come back here, you come here. Alright, let's play this game. Alright, let's see whether I can get this game over condition or not. Alright, let's play this game. 3 to swap, so yeah. Let's just come back here because it is taking so much of time to play this game. Let's come back here. Okay, yeah. Alright, let's just game over banner. Let's take this game over banner and I'll try to do some move count. Alright, I'll try to do some move count. I want to see how many moves did I make to win this game. So my move count, I shall take this move count as 0. Initially it is 0. Then I also want to write my move count as banner, move count banner on the screen. So for this I'll have to take this only the size. I'll change the size. I'll work with the same font, but I'll make changes in my font size in the move, and all the times I should write this move. For the purpose I have to bleed it here while running all the time. When I'm running all the time, I shall have to bleed it here. Alright, so game over print, yeah, game over print is equal to game over font, game over I want to print. So when so I have implemented this game over logic, but I have to also print in the game canvas that whether this particular game is over or not. I shall have to print this in my game canvas. So for this, my game over font, I'll have to render it with the game over banner. Then there is a true, and then there is a color. What color I want to write? Let's take this color 25 to 20 to 55 to 55 0. Yeah, let's go with this color. Game over banner, game over print. Let's go with this color. Then screen. Now screen dot blade with the screen. I'll say this game over print. Alright, I shall have this game over print. Alright, screen dot blade game over print. So in a position say 950 to 100 x 950 y 100, I shall print my game over. Alright, so let us run our code again. Let me check just here. Let's just do this move count. If move count is equal to if move count is 0, then I do not want to write move count. So for this, move count render will be blank. If move count is 0, then I want to write my move count is 0. So my move count render will be black. Move count render, yeah, this move count render. Alright, now if my move count is this, let's go ahead. Move count, logic for move count. Alright, so if my move count is this, alright, so we'll write implement the else part of this. So if move count is not 0, then else. I'll just copy this part. I'll paste it here. And I'll make the necessary changes here. Now if the move count is not 0, then I'll have to show my move count. So to do this, I'll have to simply concatenate my move count banner with the move count variable. I'll just go here. Yeah, I'll just come back here. I'll just concatenate here my move count with this move count variable. for this concatenation part, I'll have to convert it to a typecast to a string variable, and I'll just this concatenate this move count. Yep. And I'll have to split this. Okay, I'll have to split my move count in the screen. So for this, I'll have to write screen.split. I'll have changed this game over print. I'll have changed this game over print to this move count render. Yeah, this move count render I'll copy from here and I'll paste it here. Yeah, this move count render. Yeah, and I'll change the print position. 1050 is my X position and 200 is my Y position. Alright, now let's run this code to see how the effects are coming. Yeah, but there is a problem. I see that there is no desired output because I'm not able to see my move count. So what is wrong about it? I'm not able to see my move count. Okay, let's check here. I think I have not implemented my move count. Am I implementing my move count? Let's check that. Yeah, when I am making the moves, am I implementing? No, I don't think so. I'm not implementing my move count. So let us do this. Let us implement our move count. Move count plus equal to 1. Alright, let's run this code again to see. Yes, right, fine, sweet. Now I have got my move count. Okay, every time I am making a legitimate move, my move count is getting increased. Alright, my move count is getting increased. Perfect. So let's now work with this game over logic a little. So I have got my move count fine, but I think I should make some changes to my game over logic. Alright, so let's come here, this game over logic, because I just want to make this move count when my game is under play. Okay, when my game is not over yet. Okay, I want to make this move count and I want to make all these tiles selected, tiles movable and all these cell found cases when my game is still live. Okay, so if my game over is equal to false, when my game over is equal to false, then I want to do this. I will work with a little bit indentation part here. When my game over is equal to false, yeah, it means my game is not over yet. I will do a little indentation here. Let's run this code again to see whether the changes are coming in place. Yeah, it is working. I have no problem till now. Alright, this game over thing is done. But there is a move count is showing, but why I want to print the moves string as well? I want to print the move string over this. So how do I do this? Yeah, here I'll change this my move count banner to moves. Yeah, move count banner to moves, and let's run this code again to see whether I'm receiving this. Yeah, right. I'm getting moves, and when I am making the legitimate moves, I am getting increased the numbers. So alright, so my move count logic is done. Alright. Now I want to work a little bit on the start position. Okay, I want to work a little bit on the differential start position. For this, I'll create two attributes. For differential start position. Yeah, for differential start position during mouse click. So I'll create two attributes. Diff start position, mouse click. Yeah, mouse click X. Right. Alright, I am initializing it to 0 and I am making the same changes for Y. For Y position, that is also being initialized to 0. Alright, now I want to implement this during my mouse click. During my mouse click, when I am determining that whether I am clicking on whether my cell is selected or not. Yes, now I want to do this. Alright, let's see here, let's copy from here. Yeah, let's copy from here and I'll come back to my mouse click and I'll make the positions here. Right, let's paste it here over here. Yeah, this my differential start position X. I want to change it for my XM click, which is my mouse position click, will be implemented by my position X. XM click, this my mouse differential start position x is equal to mouse click minus my difference minus my start position x. My start position x, I'll change this to y. This y m click, and also the start position y. Alright, I think I'll get a smoother effect now. My effects will be a little bit little more smooth now. Let's run this code. Let's check this. Perfect. I am getting a smooth experience now. Alright, when moving the tiles, I'm getting a smooth experience. Alright, now let's work on this replay logic. Okay, what if I want to replay my game over and over again? If I do not have to close my game, but I want to implement a replay button inside my game. Alright, because when I'm trying to replay my game, I want to do this. So how do I do this? Let's come back here and let's do this replay. Let's work on this replay button logic. For this, first I will create all the new variables that I will require. For this replay font, I will work on a replay font, and my font code is same as above. Only the some of the things will be different, but the basic will be the same. That pygame.font. Yeah, let's copy from here. All right. Now pygame.font. Okay, I'll change this. The variable name I'll change, and I'll come back here. I'll also change the size. Of the font to 35. Alright, my replay font. My replay font is now ready. Now I will do something on this replay print. Alright, my replay print. This is another variable replay print. Let us do this replay print equal to replay font dot render. I will have to render my replay font. Whatever the replay font I have created, I will have to render it. Alright, for doing this rendering, I will do this replay. In the replay button, I will want to write this replay string. Alright, this replay, then true. This is same as, because we have done this font thing so many times in this particular code, so I am not repeating it. So replay true 0 255 0. This is the color code. With this, I want to this replay, and then I want to this replay button. Alright, this replay button color. I want a replay button color. Let's take a random color like 165 42 42. Let's take this replay button color. Alright, so I'll have a replay button. My font is this, my rendering is this, my color is this, and now I'll have to work on this button length and button width. So let's take a button length of, let's say, button length and button width. This is going to be the dimension of my replay button. So my button length and button width, yeah, this is like 150 by 150. It's not 0. Button width, yeah. Let's come back here. It's not 0. It's 50. So I'll have a replay button of size 150 by 50. Now I'll have to declare a start position for this button. So this is the dimension of the button, but where in the canvas the button draw will start. For this, I will do this say button start x and button start y, and let's take this 1065 and 300 is x and y value for this button start x. So with this I have done all the required variables for my replay button. Now coming to the replay logic. When I'll click on this particular replay button, no, I'll have to catch this. When I am clicking on this replay button, I'll have to catch that I have clicked on the particular replay button. Okay, for this I'll do this XM click, where I have my click, the X position of my click, it should be greater than the button start X, and it should be greater than button start X, and it should be less than button start X from where the button started, and the dimension of the button and the length of the button. Okay, so button start X and XM click will be less than my button start X, yeah, plus my button length. Alright, yeah, my button length. Okay, and very similarly I will do the Y thing here. I will do the Y position here. For this is same as the X, only the X thing will be changed by the Y thing. Okay, so let's copy this one, and let's paste it over here, and let's change all the x with the y here. Alright, let's come back here. This is my y, ym click, button start y should be greater than button start y. Yeah, it should be greater than button start y, and it should be less than my xm click and my button start y plus my button width. Button start y plus my button width, the width of the button. So by this way I am ensuring that my button click, by this way I am ensuring that my button click is done on the right position. Alright, so I have clicked on my button. So with this I have clicked on my button. Alright, perfect. Alright, so once my button click is done, once I have clicked on the right place of this button, what are the things I am going to do? So I want to initialize my variables. For this I want to initialize my move count variable to 0, my game over banner if my game is already over, or if it is not already over, I will not take a chance and I will just game over banner, I will just initialize it. So tiles, for all the tiles object I want to clear all the tiles object, because I want to create new tiles object with totally new orientation, because I want every time I click on this replay button, I should get a random game. I should get a random game to play for. Okay, for this I want to delete all the objects. I want to clear off the objects by this tiles.clear. Now let's also initialize the matrix, the 3 by 3 matrix that we cleared, for which is actually recording my progress of the game. I want to initialize this. For this I want to initialize my row positions, and I want to initialize my y positions. So this is how I initialize my x positions and y positions, my row positions and my column positions. Alright, now my game over should also be false. I want to initialize my game over to false once I click the replay button, and my move count should also be false. My game move count should also be false. Alright, my game over banner, I want to initialize my game over banner so that I can have a feel of a new game every time. Perfect. Alright, now my position, I want to initialize my position as well. Now tile number I want to initialize as well. So all the important variables which are there in my driver code, I want to initialize all of them, almost all of them. Alright, my tiles list where I am storing all the tiles object, I need to initialize it too. And then when all the initializations are done, I want to create fresh tiles. So for this I will call this create tiles method. Alright. So far so good. So my game over logic, I think I have done my game over logic. I think I have done my replay logic. Alright, now let's come here and let's print this. Button. Alright, for this I'll just draw a rectangle. So pygame.draw.rect, and inside the rect what I'll do, I have already done this so many times, so I'll just simply write it here. So I want to pass my game screen, my replay button color, with this color a rectangle will be drawn, and this pygame.rect, I'll call this method pygame.rect so that I can create a rectangular at that particular position. Yeah, rectangular. Alright, at the button start x and button start y, this is where my rectangle will start. Alright, so and this is going to be my dimension of the rectangle. My button length and button width, this is going to be the dimension of the button. Right, so I have drawn a button, I have written a replay logic, and I have drawn a button. Alright, let's do this print it dot blade, because I want to print this. Okay, I want to print this as well. Alright, let's do this replay print. Right, so on the button, on the face of the button, I want to write this replay thing. Alright, so position, let us give 1080 and 308, x position and y position 1080 and 308. Let us work on this. Perfect. Let's run this code. I got some error, some colon is missing. Alright, let's see, let's come back here where I have done, I think the if else part, for calling this replay button logic for this, I think I have missed it here. Okay, alright, I have provided it. Let's run my code again to see whether I am getting my error. This is another, no, it is now the replay. Yes, I can see the replay. I can see my replay button is coming. Alright, my replay button is coming. Let's click on it. But I have an error, create tiles. I think there is a typographical mistake. Create tiles, there is a typographical mistake because I have created this create tiles. I am calling this create tiles method, create tiles function from my replay button code. So let's go to my replay button code and see if my create tiles function is spelled properly or not. Let's go there. Let's go there in my replay where I am clearing. Yes, there is a typographical mistake here, so I should change this to tiles, create tiles. Alright, let's run this code again. Right now when I am clicking at the replay, I am getting a totally new game with a totally new game. Let's play this game a little to see whether I am getting it. Alright, good. Let's play this game a little further. Yeah, after playing a certain moves, if I want to replay my game, that is also possible. Fine. So my replay logic is done. Now let's work on another logic that is called my best move. So when I am playing the game continuously, I want to beat myself. Okay, whether I want to know how good I am doing. For this, let us implement this best count logic. Alright, so I have just copied the move count portion and I'll just make the suitable changes here. Some best move count is 0, my best move count is 0, and then my best move count banner. I'll change this my best move count banner and my best move count font. It is going to be the same font, only maybe the size. I'll just change the size, but the rest of the things will be fine. In the banner, I shall write best moves. In place of moves, I shall write best moves. And in the font in which I am writing, I will use the same font but with a different size. Maybe it is a smaller size of 30. Yeah, so this is how I am going to write this best move. So these are all the variables which are required for implementing this best move logic. Alright. Now my variable part is done. Let us do this best move. Let us do this best move. So yeah, here I'll have to print this. Now if my best move is equal to 0, I do not want to print anything. If my best move is equal to 0, I do not want to print anything. For this, yeah, my best move render. If my best move is equal to 0, my best move banner, my best move count render. Yeah, my best move count render is equal to my best move count render. I'll change this render. I'll copy this render code and I'll come back here and I'll paste it here. Yeah, this best move count render, when it is 0, I'll make this changes. This best move count font is fine, render part is fine. Here I'll have to change this best move count. Yeah, this best move count banner, not this, the best move count banner. Best move count banner is true. Yeah, and I'll take a different color. Let's say 255 0. Yeah, this is the case where my move count is 0. Base move count is 0. And if my base move count is not 0, so I'll write a else part. If my base move count is not 0, so I have got some base move count. I want to render it as well with a string of my base move concatenated with the previous one. So my base move render is my base move font. There will be no change in the font. Only I want to concatenate this thing. Concatenate this my base move string with the base move count. For this, I'll concatenate with a string. I'll automatically typecast my base move count and I'll concatenate with this banner. So this is by writing the plus, I'm concatenating, and by using the str method, by using the str method. Alright, let's just write this here, the based move count. Perfect. Fine. So this is how my based move count banner will be shown. My based move count will be shown, and I'll, as usual, for writing anything on the game window, I'll have to blend my screen. I'll have to illuminate my screen. I'll have to blend my screen. Let's do that. Screen.blend equal to best move. Screen.blend equal to, yeah, this based move count render. Perfect. So let's run this code. Yeah, this is where I'll see this 1080. This is where it will be shown 1080 x positions and y positions for this based move count. For based move counts to be shown, I'll have to do this. All right. Yeah, okay, fine. Yeah, let's run this code to see. Let's play this game a little further to see if I can get a based move. Let's play. All right, 3 4 1 7 2 3 7 2 3. So 1 2 3 4 is arranged. So 5 4 5 7. Let's, what do I do? 7 8. Yeah, let's move 8 here. 5 4 5 6. My game over, but my base move count is not coming, and there is another problem. My 7, my game should not be overhead because 7 and 8 is not positioned. So there will be yeah, there is some problem with my game over logic, and there is some problem with my base move count. Yeah, let's fix them. Let us fix them one after another. Let's do this base move first. Let's do this base move first. My base move. Yeah, for doing this base move, let us go to this game over logic. Yeah, in my game over logic. So once my game is over, then only I can say I have got a best move. Alright, then I'll have to compare whether my best move is better than the last best move. So inside my game over logic, so if my game is over and if my best move is best move count, if my best move count is equal to 0, if best move count, alright, let's do this. Let's best move count, if this double equal to this, what do I say, if best move count is equal to 0, okay, is best move count equal to 0, or if best move count is greater than my move count, the move count is the move count of the current game. If my base move count is 0 and base move count is greater than my, or my base move count is greater than my current move count, then I'll say my base move count equal to my move count, right? Alright, and here I'll just do this 1 2 3 4 5 6 7 8 9, and it will be, should be a space, because this is how my game over condition should be, with the one more space was missing. Alright, because the last cells should be blank. Alright, so this game over banner and base move count, let's make them global variables here. This move count as well. Let's run my code one more time to see how am I doing. Alright, I think I am done here. Let's run a game. Let's play a game to see whether I get this. So 1 2 5, I'll have to move to 3 after that. Alright, yeah, 2 3 5 3 5 down. 1 2 3 is positioned now. 5 6 is positioned now. 4 5, I'll have to interchange them. For this, I'll do this 4 5, yeah, 4 4, let's bring back 4 here, yeah, 5 4 8 7 6, yep, this 8 6 5 7 6, let's 6. My game over. Thank you very much. Thank you.